These are the solutions for the review mock exam for polynomials. Number one, considering the function f of x equals kx divided by 2 to the x, given that f of 1 equals 2, show that k equals 4. So just remember that in function notation, if you put a 1 inside the parentheses, that means that x equals 1. And if you put a 2 equal to the function, then that means y equals 2. Okay, so if you know that x equals 1 and y equals 2, then figure out what k is. So we'll put 2 equals k times x divided by 2 to the first power. 2 to the first power is just 2, so 2 in the denominator. K times 1 on the top, k in the numerator. So we just have 2 equals k divided by 2. Multiply both sides by 2, and we get k equals 4. Okay, so we have just shown that k equals 4. Write down the values of q and r for the following table. And so now they're just saying, okay, for these values of x, what are the values of y? F of x just means y. So we're using the function y equals k, no, not k, because we already know that k is equal to 4. So it's 4x divided by 2 to the x. So they've already found all the values for us except for this one and this one. So let's plug in 2 in for x and see what we get. We get y equals 4 times 2 divided by 2 squared. So that's equal to 4 times 2 divided by 4, which is just equal to 2. So q is 2. And then the 8 here, let's see, y equals 4 times 8 divided by 2 to the 8th. Well, 2 to the 8th power is equal to, if you do it on the calculator, you'll see that it's 256. Okay, and 4 times 8 is, if you do on your calculator, is 32. And then, if you reduce both of these by common factors, you'll see that 32 divides into 256 8 times. So this is the same thing as 1/8, or you could find a decimal which is the same value. So we'll put here 1/8, or you could put a decimal value. Okay. As x increases from -1, the graph of y reaches a maximum value and then decreases, behaving asymptotically. Draw the graph of y for -1 to 8. Use a scale of 1 centimeter to represent 1 unit on both axes. The position of the maximum m, the y-intercept, and the asymptotic behavior should be clearly shown. So we're going to graph this function, and we already have all the points written here, right? We're just going to graph the function between -1 and 8. So let's see. So we'll start at -1 and we'll go to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. And the values of y range between -8 and 2. So here will be -8, -6, -4, -2, 0, plus 2. So we'll draw our axes, and we'll start graphing our points. So -1, -8. That would be -1, -8 would be right there. Next point is 0, 0, right there. Next point, 1, 2, right there. Next point, 2, 2, right there. Next point, 4, 1, 4, 1, right there. And then last point, 8, 1/8. So 8, 1/8, that would be like, very close to the x-axis there. And then we're just going to graph or connect the points so they kind of go like this, right? Okay. find the, let's see. Okay, so we've shown, let's show the value of m. M is like right there, right? The maximum value is right there. What else do we need to show? The y-intercept, that's the y-intercept right there, right? Y-intercept. What else do we show? Asymptotic behavior. This is the asymptotic behavior. It's approaching this line. And what's the value, what's the equation for this line? It's y equals 0. So using a graphical display calculator, find the coordinates of m, the maximum point of the graph. So how do you do that? Well, you're going to use y equals, and you are going to program the calculator with the function, which we know is 4 times x divided by 2 to the x. Okay, maybe we can't see it because we need the zoom standard. Okay, so here's the graph. You can see that it looks pretty much like what we have here. And now we're just going to find the point m. And the way we're going to do that is we're going to find the maximum here. How do we find the maximum? Second calc maximum, which is 4. So first we say a point to the left of the maximum. That's fine. Then we say a point to the right of the maximum. That looks about right. And then we say a guess. And then it says that the maximum is x equals 1.44. And the y value is 2.12. Okay. Write down the equation of the horizontal asymptote. Hey, we just did that. Y equals 0. Draw and label the line y equals 1 on your graph. Okay, so let's do that. We'll do that in a different color, blue. Y equals 1 is right there. The equation f of x equals 1 has two solutions. One of the solutions, and f of x, remember, is this equation. Okay, so this equals 1 is when there is an intersection between the line y equals 1 and this graph. Okay, so where does that intersection happen? There's one intersection there and one intersection there. Well, they say one of the solutions to x is 4. Guess what? That's this one. So they tell us that that's 4. We already know that, right? Because 4, 1 is in the data. Okay, so one of the intersections between the line y equals 1 and the graph of f is 4, 1. Where is the other one? Use your graph to find the other solution. So we can see the other solution is about here, right? So we'll just like use the graph to estimate that. It looks like it's maybe between 0 and 0.5, right? Definitely not between 0.5 and 1. So we could say maybe like 0.3 or 0.4. Okay, as for the value of one of the solutions, okay, of where the line y equals 1 intersects that graph. Okay? Okay, second question. We have two functions. F is 1 over x squared plus 1, and g is square root of x, and of course only for positive values of x. Why don't we include negative values of x? Well, negative values of x, you can't take the square root of those. So since it's a square root function, it can only be positive values of x. So sketch the graphs of f of x and g of x together on the same diagram using the values of y between -3 and 3 and values of y between 0 and 2. So let's see, -3 to 3. Let's see, if this is -3, that would be 0. And this would be positive 3. And then if this is 0, this would be 2. So now let's draw the axes. Okay. All right. Now let's draw the curves. And the way we're going to draw the curves is we're going to use the calculator. So we'll put 1 divided by x squared plus 1. And of course, you should always use parentheses around the denominator, around the numerator. 1 divided by x squared plus 1. So that's f. And g would be square root of x. Square root of x. And then we graph. Okay, so we have a little bump here, and then we have the square root function, which looks like kind of looks like the wave coming out from behind of a boat. So let's zoom in a little bit more. So we'll make the window size maybe like -5 to 5. Okay, and then we'll change the y min to -5 and 5 and graph. Okay, so it looks kind of like this. Okay. You must label each curve. F is this one, and G is this one. State how many solutions exist for the equation 1 over x squared plus 1 minus square root of x equals 0. And you might say, well, what the heck does this have to do with these two functions? And the reason why this has to do with these two functions is because let's say that you wanted to find, that intersection right there. How would you find that intersection? Well, basically, that intersection is saying, hey, that is when f of x is equal to g of x. Okay, so when is f of x equal to g of x? Well, if f of x is equal to g of x, then that would be that intersection, okay? And how do we find that point without using the calculator? Well, what we would do is we would say f of x equals g of x, and then we would just say, well, 1 over x squared plus 1 is equal to square root of x, because that is f of x equals g of x, right? And then if we just did one algebra step, subtract square root of x from both sides, we would end up with 1 over x squared plus 1 minus square root of x equals 0. What do you know? Now does this look familiar? Okay, so they're saying how many solutions exist to this. Basically they're saying how many intersections are there between these two graphs? And there is one intersection only, right? So one intersection. Find a solution of the equation given in part B. So what is the solution to this? Or what is the solution to this? Okay, well, the solution to that is the intersection point. Okay, and they're only interested in the x because the solution to this is what x causes this to be 0. And so you just need to know the x value, you don't need to know the y value. But let's find the intersection between these two on the graph. And we do that with second calc intersect 5. And then we'll just say, okay, which curve? First curve, 1 over x squared plus 1? Yes. Second curve, square root of x? Yes. Make a guess. And since there's only one intersection point, we don't need to be too specific with where the guess is. The intersection, it turns out, is 0.569 or 570, comma, 0.755. Okay? And in this case, x is equal to 0.570, and that's all they really need because they didn't ask for the intersection point. They asked for what x makes this true. And the x that makes that true is 0.570. Okay? Which also happens to be the x value for the intersection. And that's it.